Hello guys, I am Chumi from Waterbury Collegiate, and I'm here to present you guys questions 5 and 6 from the Prairie Math League High School Round 129. Yeah, this time I made a PPT so it's easier to understand. Okay, so just the question, this is the answers to question 1 to 4. Pause if you'd like to check. Okay, and then question 5, it's like a triangular array problem. So consider the triangular array of numbers 1, 2, 3, 1, 2, 3, and goes on and on. Along the sides and interior numbers obtained by adding the two adjacent numbers in the previous row. Rows 1 through 6 are shown. So what does this mean? So you see like 0 to 5 and all the way down is shown here, also here. Well, like this number in the middle is 1 plus 1, and then this is 2 plus 2, this is 2 plus 2, this is 3 plus 4, this is 4 plus 4, this is 7 plus 8. Yeah. So basically, let Fn denote the sum of the numbers in row n. So, for example, f of 3 would be 6, because 2 plus 2 plus 2 equals 6. So, what is the remainder when f of 100 is divided by 100? Okay. So basically, if we cut this triangular array in half, we can see. So this first row, like which is f of 1, it has to be 0 because there's only a 0. So we will not talk about it. The first row, if you divide it in half, it's just 1. The second row, if you cut it in half, it's 2 plus. And be careful, because here we split the 2 in half, so it's 2 halves. So 2 plus 2 halves is 3. Just remember this number. This is a half number. And then 3 plus 4 is 7. 4 plus 7 plus 8 halves is 15. 5 plus 11 plus 15 is 31. So remember, so just see this number. 1, 3, 7, 15, 31. So what comes to your mind? Well, it should be obvious that this is the 2 to the, this is a power of 2. Like the, this is a increasing power. This is a consecutive power of 2's. Sorry, I mean this is the this is the ascending power of 2's minus 1. For example, the first row, the half sum. The half sum is basically like the sum of the this half. The row 1, the half sum is 0, and 2 to the power of n minus 1. N minus 1 is 0. 2 to the power of 0 is 1. Yeah, 1 minus 1. 1 minus 1 is 0. Row 2 half sum is 1. The half sum of row 2 is 1. And 2 to the power of 1 is 2. 2 minus 1 is 1. Row 3 half sum 3. 2 to the power of 2 is 4. 4 minus 1 is 3. Row 4, and then the half sum is 7. 2 to the power of 3 is 8. And then 8 minus 1 is 7. So you get what I mean. The half sum is basically 2 to the power of n minus 1. And then minus 1 at the end. But this is a half sum. So if we times this by 2, that will be the actual sum. And you see, like, if you times this thing by 2, if you distribute this, if we distribute this to 2 to the power of n minus 1, then that would just simply be 2 to the power of n. And then we distribute it to minus 1, so that will be minus 2. So the conclusion would be the sum of the nth row, which is f of n, is 2 to the power of n minus 2. Okay, so therefore f of 100 is 2 to the power of 100. Therefore f of 100 is 2 to the power of 100. Therefore f 100 is 2 to the power of 100 minus 2. But it's impossible for us to get the exact value of this expression. But they're only asking f of 100 modulus 100. So basically they want the remainder of f of 100 divided by 100. Yeah, so we know that a pattern of powers of 2's is that the 1's digits always follow the 2, 4, 8, 6, and then back to 2 pattern. So we see is 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 2 to the power of 4 is 16. If we only focus on the ones digit, it goes like 2, 4, 8, 6. And then 2 to the power of 5 is 32. And 32's ones digit is 2. So we see that it goes back to 2. So it goes like 2, 4, 8, 6, 2, 4, 8, 6, and goes on and on. So basically, we just have to do the power, which is, let's see the power. The power divided by 4 and take the remainder. For example, if we take 6 divided by 2, 6 divided by 4, the remainder is 2. So we go to the second, so let's call this an array. We go to the second element of this array, which is 4. And we see the ones digit of 2 to the power of 6 is 4. Okay, so now it's really simple. 100 modulus 4, which means 100 divided by 4, the remainder is 0, because 4 goes into 100. So the ones digit of 2 to the 100 would be 6, because 6 is the fourth element, which 4 in mod 4 is 0. So 2 to the power of 100, the ones digit will be 6. So if the ones digit of a number is 6, that number minus 2, the ones digit will be 4. So as you see. So if we take a look at the choices, there's only one choice that has the ones digit of 4, which is E74. So therefore E is our correct answer. Okay, this is question 5. Now we'll go to question 6, which is about like some sum and product stuff. Okay, so also like I have to give you advice. If you're doing this kind of problem in like a contest, like Waterloo contest, like Kaylee or Pascal, like you should like always assume that the final terms will cancel out, because there's no way that they will like want you to like just like like do all of this. It's just absurd. Alright, so this question is, if Tn equals the sum of 1 all the way to n, and P of n equals to this pile of disgusting expression for n equals 2, 3, 4, because obviously n cannot be 1, because the first term is already t of 2, and then the final term is t of n. If the final term is t of 1 and this is t of 2, that wouldn't make any sense. So it's only for n to 2, 3, 4. And then they're asking you, what P 2023 is closest to which of the following numbers? See, like they don't even ask for the exact value, because it's impossible to determine. They just want to know the approximate value. Okay, so basically this question seems kind of like messy, but like it's actually really easy. You just have to know these two formulas, which I believe that you have learned in elementary school, which is Tn, which is the sum of, which is better written in sigma notation, but like here it's the sum of 1 to all the way to the natural numbers of 1 to n, and then to get the sum of it, it's 1 plus n times n divided by 2, because this is the formula of the sum of arithmetic sequences. The first element plus the last element times the number of elements divided by 2. I will not explain how they get this formula, but like, yeah, it's a pretty interesting process. And then n factorial, in case you don't know this notation, is 1 times all the way to n. Okay, so now, alright, now I will get off. Now I will escape my slideshow, and I will show you, like, because it's so hard to do it on PPT. I'll just do it. Okay, here. Okay, so basically Tn equals, yeah, you know this, and then to simplify, we will define P of n equals to because like it's like if we draw a line from here to here, because if we draw a line, the thing on top is like the numerator, and the thing on top is like the denominator. So basically we'll define P of n equals to n of n divided by d of n, which representing numerator and denominator. Okay, so n of n equals to 1 plus 2 times 2, because we already defined t of n here. 1 plus 2 times 2. divided by 2 because you have to divide by 2 as the bottom, and times 1 plus 3 times 3 divided by 2 times 1 plus 4 times 4 divided by 2 times all the way to 1 plus n times n divided by 2. And then because if we take, let's take a look at this number on the right. We see it's from 2, it goes from 2, 3, 4, n all the way to n. So it's basically 2 times 3 times 4 times 5 times 6 times 7 and all the way to n. And we see that n factorial is 1 times all the way to n, but like, who cares about timesing 1? It does no difference. So basically this expression from 2 to n is basically n factorial, which is noted here, 2 times all the way to n, which is n factorial. But we'll focus on the left side first. Okay, so the left side, this is 3, this is 4, this is 5, this is 6. So this is basically 3 times all the way to n plus 1, but it's basically n plus 1 factorial, but it misses the 2 and the 1, but 1 doesn't matter, so it's basically n plus 1 factorial divided by 2. We see here it's 3 times all the way to n plus 1, and then we see here it's n factorial times n plus 1 factorial divided by 2. We move the 2 to the bottom because that's how you do fractions, and the 2 is like, it's 2 times 2 times 2 times 2. It's basically 2 to the power of n minus 1. Why is it n minus 1 not n? Because we start from 2, not 1. Okay, so basically we miss the term of 1 here, so it's only 2 to the power of n minus 1. But luckily, the 2 is divided in this expression because we miss a 2 here. So it fills the 2 in the 2 to the power of n minus 1. It's basically n, so this makes the expression n to the n factorial times n plus 1 factorial divided by 2 to the power of n. Okay, so that's n, which is here. Okay, so now we'll focus on dn. The dn is basically the same thing, but it's minus 1 on every term. So let's think about it. What does this mean? So what does tn mean? Tn means the sum of 1 all the way to n, right? So if you minus 1, that means you just simply take off this term. It's 2 all the way to n. So if you think about it that way, that makes it a lot easier. Okay, so here d of n is basically 2 plus 2 times 1 divided by 2. You may go like, what does this mean? Okay, so basically, because now t of 2 minus 1 is basically, look, t of n minus 1, as I said, is the sum of 2 all the way to n. So it's basically, so like we follow the arithmetic sequence formula, but this time we'll have to replace 1 with 2 because the formula goes like the first term plus the last term times the number of terms divided by 2. So it's like the first term is 2, the last term is also 2 in this case, and then there's only one term because, yeah, and then divided by 2. So it's basically that, and then 2 plus 3 times 2 divided by 2 times 2 plus 4 times 3 divided by 2 times all the way to 2 plus n times n minus 1, because n minus 1 because like when the last term is 2, there's only one term. When the last term is 3, there's only 2 terms. So when there's n terms, when the last term is n, there's only n minus 1 terms, and then divided by 2. So if we take a look at that, it will be like 1 times all the way to n minus 1. So that's just n minus 1 factorial as shown here. And this thing is 4, 5, 6, and all the way to n, 2 plus n or n plus 2. So yeah, this is just n minus 1 factorial, but this part, we see it's like, if we add 2 times 2 and times 3 here, it will be 2 to the all the way, again 1 doesn't matter, so screw 1. So like, it's basically 1 to the 1 times all the way to n plus 2, but we missed the 2 and 3, so it's basically n plus 2 factorial divided by 3 factorial, because there's 3 and 2 missing, and 3 times 2 is 3 factorial. So it's noted here, n plus 1, so dn now equals to n minus 1 factorial times n plus 2 factorial divided by 3 factorial over 2 to the power of n minus 1. And we know that 3 factorial is basically 3 times 2, right? 3 times 2. So we move the 2 to here, and again that just becomes 2 to the power of n. So and then so that becomes 2 to the power of n, and then we move the 3 down. It's just basically n minus 1 factorial times n plus 2 factorial over 2 to the power of n times 3. Okay, so now we combine, and now all we need to get to Pn. Pn is nn over dn. So nn is n factorial times n plus 1 factorial over 2 to the power of n over dn, which is n minus 1 factorial times n plus 2 factorial over 2 to the power of n times 3. Okay, so we see that like we can throw this thing up there and throw this thing down here, because the numerator is a numerator divided by something. It's basically the denominator, and if the denominator divided by something, it's basically timing something on the numerator. Yeah, just elementary math. And then we throw this thing upwards or downwards. We get 3 times n factorial times n plus 1 factorial over n minus 1 factorial times n plus 2 factorial. And by the way, the 2 to the power of n cancels out. So, and then, okay, so this part is like, if we take n minus 1 factorial out of both terms, what do we get? So we see like we leave the 3 alone, but like you see here, n factorial is basically n minus 1 factorial times n, right? Because n factorial is only n times bigger, because it's n minus 1 factorial is 1 to n minus 1, and like n factorial is 1 to n, so it's the only n difference. So if we take this out, this simply becomes n. This simply becomes n times n plus 1. This simply becomes nothing. It's 1. 1 is nothing. 1 is pathetic. 1 has no friends. And then n plus 2 factorial becomes n times n plus 1 times n plus 2. So basically, we just take this thing out. Actually, it's n plus 1 factorial squared, but like, it doesn't really matter because it's going to be cancelled out anyways. So it's n times, so it's, this simply becomes 3 times n plus n, 3 times n times n times n plus 1 over n times n plus 1 times n plus 2. We cancel the n and we cancel the n plus 1. It's basically 3n over n plus 2. We plug 2023 in, so P of 2023 equals 3n plus 3n over 10 3n over n plus 2. Oh my god. 3 times 2023 over 2025. So because we know that 2023 over 2025 is like almost 1, likely 0.99, but like, so that times 3 is basically 3. So we know that it's approximately 3, and the question is only asking for the approximate value, and it's even given us options to like, it's not even asked us to round it to somewhere. It just asks us of the like which of the following is closest. So obviously it's 2.9 D. Alright, but wait a second. It's actually none of the above, because like, wait, this question is flawed. Because you see, like, it's not closest to any of these, but like they didn't even specify what closest means. This option simply being there contradicts the problem, because look, when you ask a number like closest to something, like you have to give us options, because yeah, like you have to say like it's closer to 2 or closer to 3. You can't just like ask us what is 2.6 closest to. Like I can say it's closest to 0, but like you'll say it's closest to 2. I'll say it's closest to 2. You'll say it's closest to 2.5. So you have to specify the options. But the options here, like, obviously if we only have 4 options, I would choose 2.9, because it's almost like P of 2023 is basically 3. Actually, P of n is okay. So like, but if you give us this option, none of the above, that just defeats the whole purpose. That's like, how do I explain it? Like, that's just pointless. It's not even pointless. It's 画蛇添足, because like, it just contradicts the whole problem. It makes this question invalid, because if you write none of the above, what are you saying? Like, if we get to, okay, look, if we get, let's say P of 2023 is like 1 million. Like, who cares? If it's 1 million, would you write none of the above? So, if you write none of the above, that means you think this number is closer to any number besides these. So technically, I don't even need to look at the question. I'll just choose this one, and I'll just choose this one, and you have to give me the right, and you have to give me the right answer. You have to give me full marks, because let's say just go back to this example. Like, we can simply write 3, or we can simply write 2.91, like 2.91, like. And that will be the right answer. And we because 2.91 is closer to P of 2023 than 2.9. But like I don't even need to know what like 2.91 is, because I just have to simply choose none of the above, and technically I'm right, even though I don't have the solution, I don't have no answer. I just have to know that this is not like I just have to know that this the decimal places of this thing is more than 1, which is more than 1, which I can probably spot in like 1 second. So I think this question is slightly flawed. But I guess I guess okay, oh my god, like it's so hard to choose because I think they meant 2.9 was the right answer, but technically it isn't. E is always the right answer. Like in this case, there's no way that E isn't the right answer unless P of 2023 equals exactly 2.0 or 2.3 or 2.6 or 2.9. But that again defeats the purpose of this question. It makes this question invalid because it's asking what P of 2023 is closest to. If you're asking what it's closest to, that means it does not reach any of these values. It means that this isn't like P of 2023 is neither of these values. So either way, this question defeats the purpose. Like, this question is invalid. Okay, but this question is pretty interesting for like us to solve. So like, it's still a meaningful question, but the options just ruin it. Okay, so well, I'll see you next time.